Okay, so we're going to review for this chapter, and right now your test is scheduled for tomorrow. We'll see how much of this we get done. If we don't get it all done, then we'll have to finish it off tomorrow and have our test on Wednesday, right? So we'll see how it goes. So this chapter was based on linear relations, equations, and then we also did some inequalities as well. But a big part of this chapter was the fact that we were dealing with linear relations. So that means that when we looked at the graph of these relations, you got a line. And what distinguishes a line is the fact that a line has a slope. Because a line is defined by a geometric object that continues on in the same pattern forever. And that pattern is what the slope is. It tells us the rate of change. It tells us how the y values are changing as the x values change. So a big part of this chapter was talking about slope, talking about rate of change. But we started by looking at equations and being able to distinguish between linear and nonlinear. All of our equations have at least one variable in them. Okay, Kiana? Put your phone away, please. Most of them have two variables, x and y. And sometimes the variables are other letters, but normally it is x and y. And so they're an equation, they have an equal sign in them, they have at least one variable in them. And we said that as long as there's no exponents, that tells us that that relation is linear. When all the variables have no exponents, which means that they are power 1, it means that we have a linear relation. So this first example is a linear relation because you've got an x and a y, there's no powers on them, which again means that they're power 1, therefore linear. And so we looked at graphing linear relations a couple different ways. And the first way was by constructing a table of values, finding points that satisfy the equation. If points satisfy an equation, they lie on the graph of that equation. And so in this case here, we've got the linear equation y equals negative 1/2 x plus 2. We're going to do a table of values and then we will graph it. So when you look at the equation and the table is set up this way, x is the independent variable. It's the variable that's inside the equation. The answers you get for y depend on what numbers you put in for x. Therefore, y is the dependent variable. X is the independent variable. It's the variable that's inside the equation. So those are the numbers we're going to start with in our table. And our table's set up that way, where x is the first column. And when we look at the equation, what we need to do once we choose x values, we have to multiply them by negative 1/2 and then add 2. But because we're multiplying by 1/2, negative 1/2 actually, but 1/2, because of that, I'm going to start with even values of x because it's just easier to take half of an even number. So I might choose values like, let's say, negative 4 as my first value for x. And then maybe negative 2, and then maybe 0, and then maybe positive 2 and positive 4. I'm choosing even numbers of values of x to start with so that it's easy to take half of them, actually negative 1/2. So for each value of x, I'm going to plug it into the equation to get my y value. And we said this before, you can use your calculator to help you do these if you want. So the first x value is negative 4. The equation says negative 1/2. So I can go negative 1 over 2. There's negative 1/2 times x, which for our first x is negative 4, and then plus 2. Christy, get this? So there's our answer for y. When x equals negative 4, y equals positive 4. What about when x is negative 2? Well, I can retype this in. Negative 1 divided by, try that again, 2 times negative 2 plus 2 gives us positive 3. When x is 0, negative a half times 0 is 0, plus 2 is 2. And you should see a pattern here. As x increases by 2, okay, I started with negative 4, negative 2 is 2 more than negative 4. Then I went to 0, which is 2 more than negative 2. I had x increasing at a constant rate. Look what's happening to y. It appears that it's decreasing at a constant rate of 1. It's going down by 1. Let's see if that pattern continues. My next x value is positive 2. So in this calculator, I can get my previous equation that I typed in there and just edit it. So when x equals positive 2, I get an answer of y being positive 1. Again, that's that same pattern. The values of y are decreasing by 1 as x increases by 2. So the last one I have, it should be 0 for the y point, but let's see. Negative a half times 4 plus 2, yep, is 0. So my points are the point negative 4, comma, positive 4, negative 2, comma, 3, 0, comma, 2, 2, comma, 1, and 4, comma, 0. And I can put those on a graph. Negative 4, comma, 4, negative 2, comma, 3, 0, comma, 2, 2, comma, 1, 4, comma, 0. So we can draw our line. It'll look something like this. Right? This line has a negative slope because as you go left to right, the line is falling. So that represents a negative slope. Okay? And that slope is the rate of change. And we learned that you can also graph a line by getting the slope and y-intercept. As long as the equation is in the form y equals mx plus b, which means you've got y by itself, it tells us the slope and the y-intercept. So if we look at this equation, it is in that form. Y equals, y is by itself. So on the other side, you have two terms, the term with the x and the constant. The constant tells you the y-intercept. It's plus 2. That's the plus 2 part of the equation, which is where the graph crosses the y-axis. And the slope is the coefficient of x, negative 1/2. So from our y-intercept, if we rise negative 1 and run 2, we get that point right there. Rise negative 1, run 2, we get that point right there. Or we could rise 1 and run negative 2, which gives us that point. Rise 1 and run negative 2. They both work. So the slope is negative 1/2, and that is the rate of change. It is how y is changing as x is changing. And so in this case here, this table is given and we're asked to find the rate of change from the table. Well, we can do that. We notice that the x values are increasing by 2 every time. That's the pattern on the x side, increasing by 2. The y values are increasing by 4. The rate of change is the change of y with respect to the change of x. Y is increasing by 4 as x increases by 2, and if you divide those, you'll get an answer of positive 2. That's the rate of change. Okay? Now, we also saw that we can use what's known as the slope formula. Slope formula was y2 minus y1 over x2 minus x1. That's the slope formula. All you had to do is just choose 2 points. It doesn't matter which 2 points you choose. So let's say we chose that point as point 1 and that point as point 2. So you'll have x2 and y2. You'll have x1 and y1. So y2 minus y1 here would be 28 take away 16 over x2 minus x1 is 8 take away 2, which gives us 28 take away 16 is 12, over 8 take away 2 is 6, and 12 divided by 6 is also 2. So, no matter which way you do it, you get the same result. That is the rate of change. That is the slope of that line. Number 3 says, what is the rate of change for that equation? Well, that equation is in slope-intercept form. The slope is 8, the y-intercept is positive 2. But in this case, we don't care about the y-intercept. The rate of change is the slope, and the slope of this line is positive 8. There's no work to do for that. It's in slope-intercept form. You've already got y by itself. Same thing with the next one. What is the rate of change? Well, this is a line. The rate of change is equal to the slope. So we can, if we take the 2 points that are given, whoops, if we take the 2 points that are given, and we write their coordinates down. So this point is the point 0, 100. This point over here is the point 20, 1100. The rise, because remember slope is rise over run, and also remember that the letter M is often used to represent slope. So the rise is the difference in the y coordinates. Now we could write the coordinates of this point up here on the y-axis. That would be the point 0, 1100. And so the rise is the difference between 1100 and 100. Right? It starts at a height of 100 on the y-axis and goes up to a height of 1100. The difference between those two will be the rise, which would be 1000. Do I have to take that away, Keanu? You better put it away then. Over the run, which will be the horizontal change here, the difference between x equals 0 and x equals 20. So the slope, the rate of change, is 1000 divided by 20, which I think is 500. No, 50, sorry. So there we go. That's the rate of change. That's the rate of change. Number 5 says create an equation that relates the number of squares in each figure to the figured number. Complete the table first to help. So figure 1 has 5 squares in it. You just count them. There's 5 of them there. Figure 2, if we count up all the squares, it's 1, 2, 3, 4, 5, 6, 7, 8, 9. Figure 3 has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And so you should notice a pattern here. As n, the figure number, goes up by 1, s, the number of squares, is increasing by 4. So we will assume that that pattern continues. As n goes up by 1, the number of squares in each figure will increase by 4. Now, we want to write the equation for this relation. And we're going to write it using the slope and the y-intercept. Remember, our equation for slope-intercept form is y equals mx plus b, where m is the slope. The slope is the rate of change. The rate of change is asking, how does y change as x changes by 1? And that's what's happening in our table here. X increased by 1 every time, and y increased by 4. The rate of change here is as y increases by 4, x increases by 1, and it's the rate of change of y, or it's the change in y over change in x. So in this case here, m, the slope, is that the change in y is 4, as the change in x is 1, and 4 divided by 1 is 4. That's m. That's our slope. That's what we put in front of x when we're writing the equation. It's going to be 4x plus or minus something. And that something is b, which is the y-intercept. In this case here, we can determine what the y-intercept is. Remember, the y-intercept is where x is 0. Or in this case, it'll be the value of s when n is 0. And we can get that number by just continuing the pattern. When we filled out our table here, we started with n equaling 1, and we increased by 1 as we went down. Well, you can go backwards as well, meaning when n is 0, instead of adding 4 as you go down the list on the right, we can subtract 4. And 4 less than the 5 is 1. This would be the y-intercept of this graph. The y-intercept is where x is 0. So in this case here, the s-intercept is when n is 0. And so b, the y-intercept is plus 1. We just continued the pattern going backwards in the table. And the equation of this relation is y equals 4x plus 1. Now we can check that. Okay, Shaila? We can check that. Let's check this last point when n was 6. That's the same thing as x. And in fact, sometimes you'll see the equations written with the variables from the table. In this case here, it would be s equals 4n plus 1. Because instead of x in the first column, it's n. Instead of y in the second column, it's s. And if I check this last point in the table when n is 6, in this equation here, 4 times 6 is 24, plus 1 does equal 25. So it checks. Okay? It checks. Part B says use the equation that you found in Part A to determine the number of squares in Figure 7. We can look at the table and know what the answer is going to be, but we're just going to make sure we get the same answer with our equation. When n is 7, that's one more past the last entry in this table. And as n it goes up by 1, s increases by 4, so the answer should be 29 for the number of squares. But we're going to check. S equals 4 times n, which would be 7, plus 1. 4 times 7 is 28, plus 1 does equal 29. And then it says use the equation that we found to determine the figure number that would contain 49 squares. So our equation is s, the number of squares, equals 4n plus 1. In this case, we're given that s, the number of squares, is 49. We want to know what the figure number n is. So we need to solve this equation for n. This is what we did last chapter, right? We solved equations. So here I would subtract the 1 from both sides first. 49 take away 1 is 48. And then I would divide both sides by 4. And n would equal 12. 48 divided by 4 is 12. So there's the equation that we use to find that. All right, so this is what we did on Thursday. Davis has been told that the perimeter of a rectangle is 84 centimeters, and that length of the rectangle is 6 centimeters less than 5 times the width. Determine the dimensions of this rectangle. The perimeter is 84, so that's the distance all the way around. And you might find it helpful to draw a diagram, draw a rectangle. And so the rectangle has 2 lengths and 2 widths, and the perimeter, the distance all the way around, is 84. If you add up all 4 sides, you'll get 84. Now we're told the length of the rectangle is 6 centimeters less than 5 times the width. The length is being compared to the width. So if I let W equal the width, then the length is 6 less than 5 times the width. So that would be 5W, that's 5 times the width, less 6, subtract 6, that will equal the length. That's an expression for the length. You see, you need an expression for both the length and width in terms of the same variable. You can't have 2 variables here in an equation to solve it. You can only have 1 variable. And because the length was compared to the width, I started with a variable for the width, and then I could write my expression for the length. So now we can write our equation. The perimeter, there are 2 widths plus 2 lengths, and the length is 5W take away 6, and altogether that would equal 84. So 2 times 5W take away 6 would be 10W take away 12. 12W take away 12 equals 84. When you combine the W's, like those are like terms. Remember, you can add and subtract terms as long as they have the same variable with the same exponent. So they're both W to the power 1 terms. We can combine them. So now we're going to solve for W. So we would add 12 to both sides. And that will give us 12W on the left equaling 96 on the right. And our last step then would be to divide both sides by 12. And that gives us W by itself on the left. On the right, 96 divided by 12 is 8. So there's our width, 8. Our length is 5 times the width, take away 6. Shyla, you with us? 5 times 8 is 40. 40 take away 6 is 34. So there's your dimensions. 8 centimeters by 34 centimeters. And we could check that with the 2 criteria that we're given. The first being that the total perimeter is 84. So if I go 34 plus 8 plus 34 plus 8, I get the right perimeter. Also, the fact that the length is 6 less than 5 times the width. The width is 8. 5 times that is 40. Take away 6 is 34. So that's the right number for the length. Okay, number 7 says Grant decides to rent a movie theater to celebrate his birthday with all of his friends. The theater charges $200 plus $8 per person for popcorn and a drink. Create a linear relation to model the situation using C for the cost, N for the number of people. So the total cost there's a flat rate of $200 plus $8 per person to cover the popcorn and the drink. And N is the number of people. So there's our relation. Now, normally we've been writing them in slope-intercept form, which means that you'll have the term with the variable first on the right side, the term without the variable last. Remember, the term without the variable tells you the y-intercept. The term with the variable tells you the slope, the rate of change. In this case, it's $8 per person. That's the rate of change. That's how much each person is charged for a popcorn and a drink. So use the relation to find out how much grant would be charged if 220 people attend the party. So that'll be the cost when N equals 220. So 8 times 220 is 1760 plus 200 is 1960. So there's the answer to that one. Part C, use the relation to determine the number of people that attended if he was charged $1,680. So again, if we start with our equation, in this case, we're given the cost is $1,680. We want to figure out what N is, the number of people. So we need to solve for N. Our first step would be subtracting 200 from both sides. So on the left, 1680 take away 200 is 1480. On the right, the 200s cancel, so you're left with 8N. Then we will divide both sides by 8 to get N by itself. So 1480 divided by 8. 185 people attended the party if the cost was $1,680. Graph the lines using y equals mx plus b to find the slope and y-intercept. So again, when you have y by itself, there's two terms on the other side, usually. A term with the x, a term that doesn't have the x, which we call the constant. The constant tells you the y-intercept. So for this first one, it is a line because there's no exponents. It is in slope-intercept form because you've got y by itself. The slope m is the number in front of x. It's 2 or 2 over 1. Now we could also say it's negative 2 over negative 1. We did this because when you divide those, you're still going to get positive 2. And b, the y-intercept is negative 5, or the point 0 comma negative 5. The y-intercept is where the graph crosses the y-axis. It is where x is 0. So that's where we start. We start with our y-intercept, negative 5. And then we apply our slope. Our slope is 2 or 2 over 1. We can rise 2 and run 1. Rise 2 and run 1. Rise 2 and run 1. And we can continue that pattern. Or we could rise negative 2 and run negative 1, which goes down 2 and 1 to the left. All those points line up so we can draw our line going through. And you have to remember that we always put arrows at the ends of our lines to show that that pattern continues forever. Those arrows must be there. So there's the graph. The slope is positive 2, and because it's positive, the line rises as you go left to right. All right, the next one is a line because there's no exponents, and it is in slope-intercept form because you have y by itself. M, the slope, in this case, is negative 2/3. So we said that you can either put the top number negative or the bottom number negative. It doesn't matter. When a fraction is negative, either the top or the bottom is negative. And B, the y-intercept here is 1. That is the y-intercept. It is where x is 0. It's the point 0, comma 1. And that's where we start, at 0, comma 1. And now the slope, we can rise negative 2 and run 3, rise negative 2 and run 3, rise negative 2 and run 3, or we can rise positive 2 and run negative 3. Rise positive 2 and run negative 3. All those points line up. This line has a negative slope, and because of that, it falls as you go left to right. Remember, the slope of the line is the rate of change, and if it's a line, that rate of change is always the same. It never changes. Now, these next two equations are lines because there's no exponents. However, they're not in slope-intercept form. We need to put them in slope-intercept form by getting y by itself. So for this first one, we would subtract the x from both sides and also add 2 to both sides. The x is a positive x, so we subtract it from both sides. The 2 is a minus 2, so we add it to both sides. So on the left, x minus x cancels, negative 2 plus 2 cancels. We're left with y by itself equaling negative x plus 2 on the right. Now it is in slope-intercept form. We've got y by itself. And on the other side, we have two terms, a term with x and the term without the x. The term with x tells you the slope. The slope in this case is negative 1. It can either be negative 1 over positive 1 or positive 1 over negative 1. When a fraction is negative, either the top or the bottom is negative. And we always put our slope as a fraction because slope is rise over run. So if it's not a fraction, we put it over 1 to make it a fraction. And B, the y-intercept is 2, which means the point 0, comma 2. It's always on the y-axis, so x is always 0. And that's where we start, 0, comma 2. And now we'll rise negative 1 and run 1. Rise negative 1 and run 1. And we can continue that pattern quite a ways. Or we could rise positive 1 and run negative 1. Rise positive 1 and run negative 1. All those points line up. So we can draw our line going through them with an arrow on the end. Arrows on the end, I should say. Again, this slope is negative 1. And because of that, the line falls as you go left to right. That's what a negative slope does. Question D, that is a line because there's no exponents, but it's not in slope-intercept form because we don't have y by itself. To do that, I think the easiest thing to do would be to start by adding the 3y to both sides. So they cancel on the left, and you're left with 2x plus 9 equals 3y. Then, to get y by itself, we would divide everything by 3. So on the left, you'll have 2 over 3x plus 9 divided by 3, which is 3, equals y, or y equals 2 over 3x plus 3. Now we put it in slope-intercept form. We got y by itself. So that tells us two things. It tells us the slope, m, is 2 over 3, or we could also say negative 2 over negative 3, because a negative divided by a negative is still a positive. And B, the y-intercept, is 3, which remember is where x is 0. It's where the graph crosses the y-axis. And on the y-axis, x is 0. And that's where we start. We start at the y-intercept, 0, 3. And now we can apply our slope of positive 2/3, rise 2, run 3, rise 2, run 3, or negative 2 over negative 3, rise negative 2 and run negative 3, rise negative 2 and run negative 3. So there's that slope, or that line, I should say. The slope is positive 2/3, and because it's positive, it rises as you go left to right. Number 9 says a pizza restaurant has a basic charge for a medium cheese pizza plus an extra charge based on the number of extra toppings besides cheese that are added. Table shows the amount paid depending on the number of extra toppings that were added. According to the information above, what is the cost of a medium cheese pizza with no extra toppings added? So look at the pattern here. As the number of extra toppings increased by 1, Arpit, are you with us? The total cost is increasing by $2.50, right? And to get that number, you could take the 13 and subtract 1050, or you could take the 1550 and subtract 13, or you could take the $18, take away 1550. Doesn't matter. It's the same answer every time. That's the rate of change in this case. The price of the pizza is increasing by $2.50 for every extra topping that is added. But in this case, we want to know the price of the pizza without any extra toppings. So we need to go backwards on the table, which means we have to know the total cost when the number of toppings is 0. So we're going backwards on the table. On the right side, you're adding $2.50 as you go down. So if you're going to go up, you're going to subtract $2.50. So the answer here would be $10.50 take away $2.50, which would be $8. So we did something like similar to this earlier today, where we needed to find the y-intercept on the table, and this is exactly what we're doing here. We're finding the y-intercept, the cost when the number of toppings is 0. The value of y when x equals 0 is the y-intercept. So we have our answer here, $8, and we got it from the table. Number 10, use the graph to answer the next question. Which of the following statements is the best interpretation of the graph to the left? So look at the 4 statements. We want to know which one is the best interpretation. The first statement says that an airplane is at a height of 2,000 meters and descends at a constant rate of 300 meters per minute. So the first part of this statement is correct for the graph because it starts at 0, 2,000, the y-intercept. But the second part that we're given is that the rate of change is 300 meters per minute. So let's find the rate of change. Let's find the slope of this line by finding the rise and the run between any 2 points. It doesn't matter which 2 points you use. So I'm going to use those 2 points. The points are 0, 2,000, and this point here is the point 2, 1,600. Obviously, on this graph, the height will be on the left, on the y-axis, and the time in minutes would be on the bottom. So if I want to find the rate of change using these 2 points, it's the change in y divided by the change in x. So y is decreasing by 400 from 2,000 down to 1,600. So that's a negative 400. And the change in x goes from 0 to 2. So this actually gives us a rate of change of negative 200. That means that it's descending at 200 meters per minute, where this one, statement A, is saying 300 meters per minute. So it's not that one because this number is wrong. From the graph, if we're talking about the height of an airplane changing, it's changing by 200 per minute. So that's why A is not correct. B says an airplane has a height of 200 meters and drops to 1,000 meters, then flies at this altitude for 10 kilometers. Well, that's not true, according to this graph, because if it flew at a height of 1,000 meters for 10 kilometers, you'd have a section of the graph that was horizontal, going straight out at a height of 1,000 meters. So that's not it. So C is giving us a different scenario, talking about saving money. Sam has 2,000 saved and increases her savings by 200 per year. So the starting point is the same. The number for the rate of change is the same, but what's wrong with this? If it's increasing, that would be a positive slope. The line would be going upwards as you go left to right. So all we're left with is D, and this one will work because you're starting with $2,000 as a loan and you're paying off $200 each month. So that means the rate of change is decreasing by 200, which is correct for what we found. So it turns out that it's actually not height and time that's on this graph. It's actually dollars and time in years. Okay, so D is correct. Okay, so that's it. We got her done. So we will have our test tomorrow. I'll hand out the review assignment that you need to work on. And again, I would really encourage you to make sure you get this done tonight. It is due for marks. If you have any questions on any of this stuff, I'll be here by 8 a.m. tomorrow morning. You can come and ask questions. But these are the things that you need to know for your test tomorrow. There's still a whole bunch of you that didn't